right. We are live.
Okay, I just want to warn you guys, I felt like I was guessing. I felt really, really good about this whole chapter, and then when I was doing this, I was kind of disappointed in myself.
Oh.
It's all right.
I got all frustrated because I did my review thing in the textbook, and I just did number A, 2, B, 3, D, whatever. The numbers don't match up on the I'm like, gosh. Because there's like the question number 1 is the did you participate? Like,
Yeah.
now all my numbers are off.
Yeah, it's funny.
So now I'm like reopened the textbook to make sure I'm like looking at the same questions that I already worked on. Okay, so number 2. 90% confidence interval of 45 to 105 for a mean heart rate. Which of the following is the best interpretation of this confidence interval? And I have, we are 90% confident that the true mean heart rate is between 45 and 105.
Okay, I put 90% of all the people have a heart rate between 45 and 105, but I got this wrong on the last quiz, and so I couldn't remember what one. Because I like went back and I don't know why.
The word confident is in the answer when we're talking about a confidence interval.
Okay.
We can only say we are 90% confident.
Okay, that makes sense. Okay, so that's number 2, and so I just need to remember confident then if I get asked that.
Yeah.
Okay.
All right. Are we ready for question 3?
Yep.
The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see that they are approximately normal. Are the requirements for the construction of for constructing a confidence interval satisfied? Why or why not? And I said, yes, the distribution of the mean of each sample is normal since the data has been determined to be normal.
Yes.
So yeah, so that's how, I wasn't sure if I was just doing that just because, since it said normal, because I'm a little confused. Just because the 20 females and 15 males, it obviously makes it over 30, so we have
but we're not adding those numbers.
Okay, so we're not adding those numbers, and so basically we're just going off of because it says that when they did the Q plots. Okay, wait, no, I actually do know this. Okay, so they said that the Q plots are normal, and then that the variance, what did they say about the variance? And the requirements are okay, sorry, I'm trying to look. And both random and they see that they're approximately.
Well, we don't have to worry about variance right now because we're not doing an ANOVA. This is just we just need to determine if the data is normal. So since there's not a large enough sample, the QQ plots is how we're determining it. So the mean of the sample is normal since the data have been determined to be normal. We can't apply the central limit theorem because our number's not high enough, but the QQ plot tells us, okay, even though our sample number is low, we can still use it.
And that's why he kept asking the central. I was trying to figure out, I was like, I obviously understand, like it has to be over 30. So I was like, is it saying, okay, yeah, that makes sense. Thank you.
Yeah, you can't add them together because they're independent samples.
I was just like trying to figure out, because I was like, they're saying it's normal. So is it normal because they're adding? So yeah, okay, that makes a lot more sense.
Okay, 4. For the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So seriously driving me crazy that I already did all this work, but my...
Hey, Eddie, I'm gonna call. Oh.
Okay, so 4 types of
confidence interval for the difference of mean.
I said independent, but was that wrong?
That is correct.
Independent.
Okay, that is
because yeah, this is the word dependent samples is referring to the paired samples, so, and yeah, telling us what boys participated doesn't tell us what girls participated, so independent.
There's no relationship.
Okay.
All
Sorry.
right,
My
question
computer is so
5.
slow today. Sheesh. Well, my husband's computer. It's not mine. Because mine doesn't do SPSS. I'm so over that, in case you couldn't tell.
I love it. All right, question 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3402.08, 4142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? And I said we would compute a 99% confidence interval rather than a 95% confidence interval.
I got,
That would be the opposite.
yeah, I said obtain balances of 90 bank customers.
Sorry. I got that one backwards.
So wait,
So,
so
yeah.
that one, so if it was the backwards question, if you wanted a bigger margin of error, then you would do the 99% confidence interval.
Right, because you're wanting to include more possibilities.
Oh yeah, because 99% is more than, I can't remember.
Yeah, we're going to have to make our margin of error wider to be sure that we are 99% confident.
Okay.
So yeah, I think you're right, Malin. The 90,
So it's,
because this is the law of large
That's-
numbers.
yeah, the denominator. I think we were going over that with you a couple weeks ago. You were
As
teaching.
n gets higher, the true mean, or the sample mean, gets closer to the true mean, which would mean we're getting closer, and our confidence interval is getting narrower. Our margin of error is getting smaller the more numbers we have.
Mm-hmm.
You confused me, Max. I was like, oh, come on, he knows this.
Sorry.
Okay, number 6.
Yeah.
Let's see.
Do you want me
Madeline,
to,
this one?
do you want me to read the whole thing, or do you guys just?
No, we're good.
Okay. So yeah, determine
tell
the
me.
margin of error for the 95% confidence interval. So this is when, wait, no. This is when we do the equation, correct?
Yeah, you do the standard deviation over the square root of n times your,
The 95% confidence interval.
yeah.
Okay, so if I did the equation right, I got 0.124.
It should actually just
Be 1.96.
1.96.
Oh, okay, so this was the trick question, just determine 1.96, okay.
Well, it ends up equaling out.
Yeah,
You do the whole formula, it just ends up equaling out. So what's your...
So I did, okay, yeah, tell me if I did this wrong. So I did 2 is the standard deviation, 2 divided by the square root of 1,000.
No,
square root of 4.
The square root of
4
The sample mean is 1,000. The number she did was 4. It's written out in a word in the problem. She randomly selects 4 drive shafts. So that's your number, your sample number.
That's how they get you.
Yeah, see, this is this is like the story of my life with math. It's right there, and I go right over it. I'm still okay. She selects 4. Yeah, I went right over that. So okay, so yeah, so if I would have done the 4, then it would have given me the 1.96.
1.96 times your standard deviation, which is 2, divided by your square root of 4, which is 2, cancels each other out, and you're left with your margin of error of 1.96.
Okay.
And then we subtract and add to 1,000.
Yeah, to find the. Oh, we subtract and add 1,000 to find the upper and the lower.
We subtract 1.96 from 1,000. 1,000 is our mean. 1.96 is our margin of error. So to find the confidence interval, we're going to go 1.96 below 1,000 and 1.96 above 1,000. So which question? This one's asking for. Oh, sorry. I'm getting ahead of myself. Yes, this question's only asking for the margin of error, which is 1.96.
Yeah, I know. And then number 7 and 8. Yeah. And then number 7 and 8, I'm going to the upper and lower. It's the 1,000. So the mean. So it's the mean plus
The lower bound is going to be minus.
Yeah, mean plus or minus the margin of error, right?
Right.
Right.
Of error. Okay. 1.6.
I don't know where they ask us to go to the 3 decimal places because
But to confuse you in case you got it wrong.
I'm just saying.
If your third decimal place is a 0, you don't have to put it. I've tested that theory before with these quizzes.
Really?
Yeah. I'm like, no, I'm writing 998.04. I'm not writing 0.040. That's improper.
Oh yeah, so that's what I should have gotten, 99.8.040.
Mm-hmm.
Yeah.
Okay. Mm-hmm. Mm-hmm.
Oh,
My gosh, babe, your computer's so slow.
We ready for question 9, or are we still doing 7 and 8?
Just trying to save number 8.
Yeah,
It's not kicking me out or anything. It's just taking its sweet time thinking about it. There we go. Shoot.
and for number 8, I should have gotten 1001.96.
Yep.
Yeah, exactly.
Have you gone through and made your notes page for your exam?
No, not yet. That's just like what I was I'm gonna meet with the tutor tomorrow, so I was kind of doing it when I was doing this. So I wrote down the formula for margin of error, but instead of using the sample size, I used, right, because n sample size?
Yeah, I used the mean on accident.
Yeah, I used the mean. So I'm
so mad. I had my notes page from exam 1.
Uh-huh.
And, of course, only through lesson 7 or something.
Yeah.
And it was just sitting in my pile of stuff on my desk. And like a week ago, I was like, whatever, throw this out. So I'm like, okay, we're going to have some old stuff. Dang it, I'm going to have to go through all the summaries again and make sure I don't forget stuff. I had to go back and write some stuff back down again.
Okay, so number 9, I was lost. I didn't know how to do it.
Okay.
Okay, so we want a margin of error that is 0.0001. So we use that formula that we just had, and we plug in the standard deviation that they gave us. And we know that we need to know what population it is, and the population is the n. So we just replace the n with an x because we don't know what that is. And then we want a 95% confidence interval. So we know we need to times that by 1.96.
Okay, so
follow? I can write it down if you want.
Yeah, okay, so I'm going to do the same formula, and so
now we're gonna do it flipped. We're solving for n now.
Mm-hmm.
Well, it is
the same formula, but if you want it to not have to work through, I mean, you can write the formula with n as your whatever, the thing you're solving for.
Okay. So we use standard deviation. And so wait, so do I just go 0.01 times 1 point?
Well, write down the formula for a second.
So if you look really careful, I'll have the formula right now. If you look at my screen real quick, you'll see it.
Oh, okay. Mm-hmm. Yeah, I see. Okay, so it's 1.0. Let me write this down. So 0.01 J over X times 1.96. So then it's the positive. So 0.0001. Okay. The margin of error.
So you see where we get all those values?
Yeah. I don't know. Right now I can't freaking figure it out.
Okay, here's the equation where it's already solved for n.
Mm-hmm.
Sorry, my my sigma there has a really long tail. I don't know why. But it will give you the same answer as Max's formula. He just plugged it into the one where we're solving for m, or where m is the equals. So this is the same thing. We've just flipped it around. So now we're solving for n. So you can plug your numbers in here.
Yeah.
It gets you the same outcome. Max is just doing more work.
Oh, I'm exercising my brain.
Yes.
I suck at that.
He's getting the pat on the back extra credit.
And then margin of error. Okay. Yeah, that makes a lot more sense. Squared by 2. Okay, so yeah, I definitely like saw that 100 times when I was going through my notes, but obviously.
See, and this is one of the formulas that I have written down on my notes page because I'm like, I don't want to remember that. I just want to do it.
Yeah, my
I
biggest
can figure it out, but
is I always have good notes, but I don't trust myself to know what I'm doing.
okay, so we've got everything plugged in.
So I got 384.16.
There shouldn't be any decimals. There should be 38,416.
times 0. Divided by 0. Oh, yeah. Okay. 38. Thank you for explaining that. Okay, I'm ready. Sorry, guys.
You're fine.
No, you're fine.
I don't have all these formulas memorized for the record. I just happen to have already gone through the chapters summaries and made my notes for the exam. So I have the formula written down.
Yeah, I know, but that's what I mean. Like I think I need to do that because I take notes every lesson. And so I flipped back to that lesson, but I don't trust myself that I know what equation I'm doing, but I should have because I was just looking at that from the margin of error to that. And of course, I just didn't even think about it. So I think I just need to go back and just have a separate sheet with none of my other notes and just, like you said, just the formulas.
Mm-hmm.
But yeah, okay, so number 10. So the mean area of the several thousand apartments in a new developed and advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion, the appropriate null and alternative hypothesis. And I said the bottom one.
Yeah, me too.
Nice. All right.
Okay, and then number 11, in a statistical test of hypothesis, we say we reject the null hypothesis with the level of significance A is, p-value is less than A, right?
Yep.
Yes.
Okay.
Okay, I like this wording better. I swear in the practice quiz in the textbook, it was like different wording. We say the test result is statistically significant if what I was like, wait, what? It made me think, do I not know what I'm talking about? Because I think it's less, but oh my gosh, well, I've never seen this wording before.
Yeah, exactly.
That bugged me.
Well, it bugged me too. Okay, so number 12, a group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their questions? And I wasn't sure, but I went with yes because there's enough data. Like there was 4 samples, enough data. But then now I'm questioning since it's 15, and obviously you don't add them. So yeah, am I wrong?
I said yes too, but I said it's because their variances are nearly equal, and it said that we could assume equalness as long as the variances were within 4 times of each other.
Yeah, so this is this was the one that I was looking for variance because this is what I remembered because I wasn't sure. And so that's what I went with because of the same thing about 4 times the number.
See, I'm confused. I hated this question. I ended up saying no, they do not have enough data because we don't know. if they're normally distributed. I mean, it says they're bell-shaped with no outliers. So we know the variance part is taken care of, but we need like QQ plots to determine, because they're small sample sizes, to determine if they're normally distributed. So I don't know. That's where I was like, are they missing this?
Yeah. That's a good point, because it's kind of like, obviously it's question number 12, and he already pointed out how we can get that with seeing a QQ plot. So I don't really know. I didn't submit mine yet, and so.
Me neither. I didn't get it done in time.
I just sit on it. I just save them all and then wait till I come here. So I haven't submitted it either.
Yeah, that's what I just wait on it. Like sometimes I'll submit it if I'm feeling lucky, but most of the time not.
Well,
what's annoying is they probably have enough data. They just didn't tell us if they've done QQ plots. So maybe they have enough data, but they just didn't tell us all. Like, we do not have enough data to tell you if they can use ANOVA. They might.
Well, what's nice about this is that we've narrowed it down to 2 answers. I mean, well, 2 answers that each of us believe. So if we put the test in and one of the other group is wrong, you can just go back and switch it.
Yeah.
Yeah. That's true.
So.
Okay. But Rebecca, I think you possibly could be right, because we don't have the
I'm so
QQ
frustrated.
plot.
We just don't know if they're normally distributed.
Yeah.
We don't know that. They might know that.
Mm-hmm.
But go ahead and, if you guys want, put the other one, and we'll just see who's right at the end.
Usually the right one, so.
I know.
That doesn't mean I'm going to get this. Okay.
Okay, so number 13, I said committed a type 1 error, and I'm trying to remember why I said that. Oh, because of the 0.05.
I went back and I found the little chart in the textbook finally. So she rejected the null when it was actually true. So that is a type 1 error. I had to make myself that little box graph of like which rule is which, or which error is which. So yeah, rejecting the null when it is true is a type 1 error.
I like to think of it as like a pyramid, and as you get to the smaller numbers, your pyramid top gets smaller, and you can only fit 1 in there. You can't fit 2 in the top. I don't know. It's bad.
Okay.
Yeah, that's a good creative. Okay, so then number 14, if the level of significance A is made very small, thereby making the probability of committing type 1 error very small, what happens to the probability of type 2? And it increases.
Yes.
Okay, so 15, the nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams, and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of the cigarettes is 1.5, but measurements on the random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. And so I was like, I put fail to reject because 1.5, why did I do that?
So if we do the whole thing, we end up with a p-value of like 0.08, except it's one-sided. So when we divide it by 2, our p-value is 0.04035, which would make us reject.
Okay, yeah, no, I didn't do that equation. So I needed to do the...
You have to actually do the, like...
You have to count how many, like, standard deviations you can fit into the difference.
Okay, what equation is that?
I did a t-test.
T-test.
What I did was I took the standard deviation, I took the difference between the two means, which is like 0.3 or 0.03, and then I figured out how many standard deviations go into it, and I put it into a probability outlet, and then I did the tail test like that.
So you don't know this, but you actually did the t-test.
Yeah.
Because that's what it is the 1.53 minus 1.5 equals your 0.03. That's your numerator. The denominator is the standard deviation divided by the square root of the sample size, which is 100. So square root of that is 10. So you end up with the equation 0.03 over 0.017. And it gives you your t statistic, and when you put it in the probability thing, then you get your p-value and divide it by half because it's, or divided by 2, excuse me, because it's one-sided. So you did the same thing, you just
Didn't know the name.
didn't do it on purpose. You did it though.
Well, all righty then. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? I said independent samples t-test.
Is that what you said, Madeline?
I said independent. I couldn't hear what he said.
Yep. That's what he said too.
Okay.
That's funny. I heard him and not you.
I stopped because then I was like, I can't hear it. Okay, and then number 17, an educator is interested in academic achievement by males and females with similar academic support. They decided to use brothers and sisters raised in the same home. Furthermore, to use brother and sister pairs when they are next to each other in sibling order. So what hypothesis test? Independent or dependent? I said dependent for if you select a brother so as to compare his academic achievement to a sister, you must include the sister in your study.
Mm-hmm.
Yep.
I missed this one on one of those, 2 lessons ago when we were learning about this. And it was like the husband-wife one. I didn't read all the answers. And so I got it wrong my first time taking it. I was like, oh my gosh, read all the answers, dang it. Fortunately, we get 2 attempts. So I went back and I was like, I totally know this. I just tried to go too fast.
I know. Happens to the best of us. Okay, and then number 18, a soil scientist collected random oil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence interval listed below, which one is appropriate for this situation? So this is when I really, really felt like I was guessing. But I went with the confidence interval for you, and the standard deviation is unknown due to the fact. Is that what you did?
That's what I got.
That's what I got.
Okay. I just.
You know, it's funny. I had to open the document to see if there was more than one column of data.
Okay.
Because the one that says for the difference of means, I'm like, oh wow, okay, do we have more than, are we comparing certain levels or from different levels of or different parts of the field? I don't know. So once I opened it and I was like, oh, there's only one column of data. So we're not comparing differences of anything.
Yeah, and that's why I felt like I was guessing, because I was like, it's just like the way he's wording it now. I feel like
He's giving you every.
Yeah.
Well, when we've done more complicated things now, we've done more complicated things, so it weirds you out when you do the simpler, when the simpler one is the answer.
Yeah, and so that's kind of how I felt with so the number 19, the term there for this 95 confidence interval, is this a trick question? Or am I actually writing down the margin of error?
There is a margin of error.
Okay, because you know how I got tricked up on the last one when you're just supposed to put 1.960 for 95%?
Yeah, but it wasn't a trick question so much as it was that the numbers came out to be convenient.
It just so happened that our standard deviation was 2 and the square root of our sample size was 2.
Okay. Yeah,
that was annoyingly confusing because it makes you think it's a trick question.
Yeah, no, now I'm a hot mess with this. I'm like, okay, so so if I did this right, I got 13.193.
That may be your mean. Hold
I
on.
didn't get
Yes.
I only wrote down the,
Yeah.
hold
That
on.
is.
that. I got 2.02.
No, I think I did write down my mean. So let me.
Yeah, 2.02.
Descriptive statistics.
Yeah, you have your mean, Madeline.
Yeah. Okay, and I think I know why, because I couldn't remember how
You can just do this in SPSS.
to. Okay, is this the carbon level? Which one are we doing again?
Yeah, dissolved
Okay.
organic carbon.
Yeah, so I did the mean because, and what is it supposed to be?
It's supposed to be the distance from your mean to your upper or lower bound absolute value.
Yeah, so what did you guys get? Because I'm looking at my thing right now.
2.02.
You're looking at your descriptives in your
Yeah,
SPSS
so this
estimate?
is what, and
It
this
doesn't
is.
tell you. It doesn't tell you that. You calculate it.
Oh, okay, my.
Because it's going to give you the mean and it'll give you the lower and upper bounds, and you just have to subtract. To find
Yeah,
it.
and so that's when I'm going to get 15.2173 and minus the mean from that, right?
Yeah.
Okay, so the reason I'm confused on this because then then when I ask for the upper and the lower level, do you write the lower and upper bound just right there, the 11 and the 15?
Yeah.
Oh, okay.
So it's actually what we round to 3 decimal places unless told otherwise. So it would be 2.025, right? For question 19.
Yeah.
Okay.
Okay, so that determined the margin of error for the 99%. Okay, so it's the mean, the upper. Okay, and so then I should have gotten 2.025, and then for question 20, wait. Okay, I'm a hot mess. Yeah, so then that's what I did for question 20.
Okay.
But it's going to be my 11.16168.
Mm-hmm.
Yep. And 21 will be 15.217.
Okay. The reason I'm confused on that is because I remember when you guys taught me that, but I'm confused now because you know how we divide. Now we learned like you divide the upper or the lower by 2 for like the new testing,
Mm-hmm.
and so that's why I'm confused now.
Well, what you do is you can subtract the upper from the lower and then divide by 2, and you'll get the same thing as subtracting the upper from the mean.
Okay, so that's what it is then.
Yeah.
Okay.
It's just a distance thing. You're either choosing the whole distance or half the distance.
Okay, yeah, and it's just basically it's easier. Okay.
There's more than one way to skin a cat.
Yeah. Okay, so we are on question. What question are we on now?
22.
Okay, 22. Okay, so out of the 4 types of confidence intervals listed below, which one is appropriate for this situation? So since it's Hummers, the Hummers and in Los Angeles and New York, they don't have anything to do with each other, right? So it would be independent.
Mm-hmm.
That's what I put.
Okay.
And it tells us to find the interval for the true difference of means. So yeah, the interval for the difference of means using independent samples.
All right, question 23. You put all that into SPS. S, and you hope to get an answer, and I got negative 423.158.
I probably got that too. I just realized the practice one was whole numbers. So now I'm like, psh, I only have the whole number answer. What is it? Negative 423.158.
Yep.
I did the math at some point, but then I just wrote down answer D or C or whatever.
Wait, you got negative 423.158?
Yep.
Okay, I just wanted to make sure because.
Yeah, I'm gonna trust your decimals here, Max, because I don't want to do this math again.
Hey, you know, it's only like 3 clicks of a button.
Yeah, he is correct.
Yeah, but my SPSS isn't even open because I did it yesterday, so.
Oh, okay, yeah. I understand.
But I do have the whole numbers, so I just trust your decimals.
Nice. All right. And then the same thing for question 24. You just hope for the best when you put your stuff in, and you get, I got at least 5,417.256.
Yes, that's what I got. 5417 point.
You know, give or take 0.256, because I don't know.
Are we all good?
Yeah.
Okay. So then you get to use exercise bone densities, and they used 3 different groups of rats, essentially is what we need to know. And there was, and so yeah. And so what is the correct hypothesis test for this situation? Since there was multiple groups, there was 3, I said ANOVA.
Me too.
Awesome. And then you plug all your good information into SPSS, and you hope to get a test statistic, and I said 7.978.
I believe that is also what I got.
That's what I got.
Okay, awesome. And the p-value I got was 0.002.
Yeah.
Oh, hold on, dyslexia. That's going to make me get the answer wrong. 7.978. I did it backward. See, this is what happens when I try to go too fast. Okay.
Max, how many more years do you have on campus?
2 more tops. Well, before they kick me out.
Oh, yeah. There you go.
Well, I already did 2.5 years on campus. How much? How many did I do? 1, 2, 3, 4, 5. Yeah, I did 5 semesters on campus.
Yeah, me too.
Oh, okay.
You know, when you were in 7th grade.
How old are you, Rebecca?
I'm 29.
Yeah, you're not that much older. How old are you, Max?
I am 21.
Okay, Max is the baby. I'm 24.
I started.
To be honest, I thought you were at BYU Hawaii.
I was. I did that that's where I got my associates, and then I got married this summer, and so I had to leave school.
Yeah, see, and I started at BYUI on campus in 2005.
Wow, that is crazy.
I know I'm not that old, but I
Musical.
feel old, right?
That's funny.
Zac Efron's like my age.
No, you're just lucky. I'm 24 and still don't have my bachelor's, so.
Well, I'm 29 and still don't have my bachelor's.
Yeah, but you were lucky when you did your nursing thing, you know?
I just got my associate when I was 20 and stopped going to school.
Yeah, but that's okay. But back then, though, you said UAU Idaho had like an associate nursing plan, right?
Yeah, no, I was done.
That is awesome. You scored.
Well, except now I'm having to get my bachelor's when I have 3 children instead of, back when I didn't have children.
That's a good point.
So
That actually does suck. Never mind.
I could have gone to school full time on campus still. We still lived in Rexburg for a year after I graduated. Well, my husband was finishing his degree. I could have finished my bachelor's in a year on campus time.
Yeah.
And still had my bachelor's before I had a baby.
What did your husband, what does he do?
His degree was business with management. emphasis. So he is a windshield sales manager right now.
Oh, okay. Okay.
Fancy stuff.
Yeah. It's a job. It's good.
It is. It takes good care of us.
Yeah.
All right. Back on point here. Sorry, I'm old. That's the.
No, it's weird for me because it's like everyone's like, "What are you doing?" Because I'm at work and they all went to lunch. And I'm like, "I have class," and it's weird how we like meet together and we do kind of know each other, but then we have no idea what's going on. So it's strange. Strange.
Yeah.
Okay, so number 28. Which of the following best expresses the conclusion of this test? And I said there's sufficient evidence for that. Yeah, to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
That's what I got.
Cha-ching.
Okay, and then 29. 29 was kind of making me question myself because it was asking for the difference. And so I wasn't sure if I was doing the different test on this, like the minus.
Okay, honestly, I had to go back. This is a couple of lessons ago. I went back and looked up my old quiz to see what I'd gotten because we've already done this question exactly.
Yeah.
On a previous quiz. So I'm like, I think it's this, but I don't remember. I know I got either it right or wrong. Let me go look at my old quiz. So let me match my practice answer to this one. Direct flights 23C. Yeah, so I got the paired.
The dependent samples test?
Dependent. Yeah, dependent is the same as the paired.
Nice.
Yeah, that's what I did because I did the same thing. I didn't go back all the way to the test, but I was like, we did this before. And so I was only, when I was looking at my notes, it was like paired, but I didn't get it. So this is when I needed to input it into my, I should have gotten a difference, right? Into my SPSS.
Yeah, we have to compute the, what is it, compute variable? Is that what it's called in SPSS?
Yeah. You
Make
go
the difference column.
You go to transform, or yeah, I think it's transform compute variable.
I hated this question because I'm like, okay, so she's comparing costs. Is she comparing the same flight?
Yeah.
Or is she comparing just the same city? Because does that make a difference on whether it's paired or independent?
Well,
They don't give us. I overthink it.
Yeah.
Like it says that she's comparing them to the same city, but it doesn't say, is she comparing flight 1234 to flight 1234, a few months later?
It's the same. It's the same distance traveled. It's so that is what makes it dependent. It's not.
Yeah, I told you I overthink it.
Yeah.
I'm like, I don't know.
Alrighty. Well, the thing is it depends on how you subtract these things.
I know.
Yeah, and that was
you could have a test statistic that's a positive or negative value.
Okay, and then is the test statistic, is it N or will it say T?
It's a T value.
Okay, because that's what how do I get that? Because I couldn't remember, and I didn't have it written down in my notes how to get that, because I just have like the descriptives of like 95% and the minimum maximum, and then I have an N number.
So after you've subtracted the two columns and you get your new column, your difference column, you run a t-test on that difference column.
Okay, so I go to analyze, descriptive. No, I go to
compare means.
Yeah. Analyze, compare means, and then
one sample t-test. It's annoying to have the paired sample as something that you can run, but we're not doing it that way. We're computing a new value or a new column of differences, and then we're only running a one sample.
Yeah, because that's why I was like completely like stalled. I was like, I don't know what to do. Okay, and then what about my test value? Is it 0?
Yes.
No.
Okay.
Because we're seeing if there's a difference.
Oh yeah, test value. Yeah. Sorry, I thought you were talking about your test statistic.
So it doesn't say here, but our null hypothesis would be that the difference is 0, because we're seeing if there is a difference or not.
Mm-hmm.
So yeah.
Okay. And then I don't know if I think I put the 14 days minus the 90 days, and so my T was 1.685.
I think I did it the other way around, so I had a negative one.
Yeah.
But on our
I had a
practice
negative.
test, they only had positive choices.
Mm-hmm.
So I'm going to
So
go for the positive in this one since we have to actually
Yeah.
enter it.
So you guys got
I'm gonna go with
685.
685.
Mhm.
But
Yeah.
yours just was negative 1.685.
Yeah, I did it the other
It's
way
so
around. I did the 90
frustrating.
minus 14. They weren't very specific.
Yeah,
No,
I couldn't figure, the only reason I did that was because of the way they were set up, because it didn't make sense. You're supposed to do, I think they said do the post minus the pre if you look at the chapter, and it didn't make sense for us. So,
Yeah.
but so I have to remember it always needs to be a positive though, correct?
Well,
Not necessarily. If the instructions
Yeah,
should be more
negative.
specific. The instructions on this one weren't very specific. I figured the reason I did it the 90 days minus the 14 days is because you got the data for the 90 days first. So then I have that data and I'm going to see what the difference is now that I'm only 2 weeks out from the flight. Like they should have been more specific in which order it needed to go. But the only right now I'm just hoping that our exam will actually be more specific.
Probably
rule
not.
of thumb, just the rule of thumb that I do is that you do final minus initial.
That's probably a good rule.
Oh, okay. So
Which
just
would then
fine.
make Wiz is what you did, Madeline, and so your answer would be positive.
Okay.
So what'd you get, Madeline, for the p-value?
I got okay, sorry, let me go right down. It's like 0.096, I think.
Yeah, 0.096. That's what I got.
Me too.
I don't feel like I'm gonna do good on this test. Like I obviously understand most of it, but I feel like I'm guessing, and so it's gonna be a lot of guessing when there shouldn't be. But it's more I'm second guessing the information I've learned.
Right. Okay, so here's the thing, Madeline. Most of the time, you're guessing correctly. So
Yeah.
your thing then needs to be, before you take this exam, you take your notes, but honestly, I think your prayer before the exam needs to be, please let me trust myself. Because most of the time you know what you're doing, you just don't know you know what you're doing.
Yeah.
So because you're like, I don't know, did I get this right? And we're like, yeah, you totally got this right. So that just needs to be kind of your thing. You know the material and you're doing your best, and most of the time you get it correct. So you just need to be able to have that calm and trust in yourself. Help me to not second guess myself so that I can take this test. And because when you second guess yourself, you're like, I don't know, am I right? Am I wrong? And then you switch your answer. Then you're going to be frustrated. So
Thank you. And I've been forgetting to say my prayers before I take the test. So maybe that's why.
All right,
Okay,
last one.
Yeah, number 32. Which of the following best expresses the conclusion of this test? Use a level of significance 0.10. So it's less. So there is sufficient evidence. 40 days in advance in it. And the mean cost for 40 days advance compared. Wait, and the mean cost of purchase 40 days. There's it's number 2, right? Because they're asking if there is a difference, correct?
Correct.
Because we're rejecting the null.
Yeah.
The answer should always be sufficient evidence. And by rejecting a difference of 0, that means there is a difference.
Okay. Yeah. Sweet. The sufficient stuff is finally making sense to me.
Let's see who got number 12 right.
Yeah, okay, I just submitted, so let's see.
Did you get number 12 right, or did I?
I got number 12 right.
Dang it. Well, I'm going to go back now.
Wait. I have a question. Let's go to freaking, where was it? It said, what'd you guys get for your lower and upper bounds again on 7 and 8?
7 and 8. Let me scroll. Did you get them wrong?
It says I put in 1001.96 and I got them wrong.
For number 8? Or did you put that in for number 7?
Oh,
you did it backwards.
backwards.
I'm like, no, that's the right answer. You just put them in backward.
No, I have to go and put all these answers back in now.
I was going to say, well, go through while you see your answers and write them all down and flip 7 and 8.
Ah. All right. Well, thanks guys
Yeah.
for all your help.
Thank you for all the
Of
help.
course.
Always good luck on your test.
Yes, good luck to both of you. If
Okay.
my quiz will ever submit, oh my gosh, my husband's computer needs to be restarted or something. This is driving me crazy.
Oh, Rebecca, I want to tell you, did you ever
Yes.
call because you downloaded it from on the hub, right?
Yeah.
Did you ever call them and have them get into your computer?
No, I called them once, I think before I even tried to download it onto my husband's computer, just like right when I very first got it.
Yeah.
And they were very unhelpful.
Okay,
I don't
know.
even remember what they did for me because it was so unhelpful. I was like, whatever, forget you.
Okay, so did you call on the hub or did you call the actual SPSS?
Maybe both.
Okay, because I called SPSS and they were no help. Like I was freaking done, to be honest. I was so mad. And then I called on the hub and they send you an email and they get into your computer and they did it all for me.
Huh.
And so you should try it.
Fortunately, because I have 2 computers sitting on this desk here, I can still access it.
Yeah.
On my
But I'm
husband's.
just saying,
Yeah.
it took like 2 minutes. So, and I didn't have to do anything. They did it all. I watched them like use the mouse and everything. I just sat there and then it's been fine ever since.
Awesome.
So yeah. Okay. Good luck, guys.
All right.
See ya.
Bye.
Bye. Yeah, give me a sec.